At 25 degrees Celsius, the specific conductance K of saturated solution of AgCl is 2.68 into 10 power minus 6, and that of water in which the solution is made is 0.86 into 10 power minus 6 ohm inverse centimeter inverse. If limiting molar conductivities of AgNO3, HNO3 and HCl are respectively 133, 421 and 426 ohm inverse centimeter square mole inverse. Calculate the solubility of AgCl in water at a given temperature. First of all, the given specific conductance of AgCl solution and water. By using that, we can calculate the specific conductance of AgCl solid. Here, specific conductance of AgCl solution is equal to specific conductance of AgCl solid plus specific conductance of the H2O. From this, specific conductance of AgCl is equal to specific conductance of AgCl solution minus specific conductance of the H2O. Specific conductance of AgCl solution is 2.68 into 10 power minus 6 minus specific conductance of water is 0.86 into 10 power minus 6. We subtract, we'll get the value 1.82 into 10 power minus 6 Simon centimeter inverse. Now we got a specific conductance of AgCl. Now we need a lambda m value for AgCl to calculate the solubility. How to calculate lambda m value of AgCl? First of all, we'll calculate the lambda m naught value of AgCl. Okay, by using the three strong electrolytes AgNO3, HNO3, HCl. Out of these three strong electrolytes, HNO3 is having two common ions. H plus is a common ion with respect to HCl, NO3 is a common ion with respect to AgNO3. So lambda m naught value of HNO3 should be subtracted from lambda m naught values of AgNO3 and HCl to cancel the common ions and to get lambda m naught value for AgCl. So based on that, the formula is lambda m naught of AgCl is equal to lambda m naught of AgNO3 plus lambda m naught of HCl minus lambda m naught of HNO3. Now lambda m naught of AgNO3 is 133, HCl is 426, HNO3 is 421. We'll get the value here 138 Simon centimeter square mole inverse. Anyway, the salt is very less soluble, so because of that lambda m naught of AgCl is equal to lambda m of AgCl. So limiting molar conductance at infinite dilution of AgCl is equal to molar conductance of the AgCl at any given concentration. Now lambda m is equal to K into 1000 by C. Anyway, K in centimeters, so 1000 by C. Lambda m of AgCl is 138 is equal to K value is 1.82 into 10 power minus 6 into 1000 by, in place of C we can take it as S solubility. We calculate S value will get 1.32 into 10 power minus 5 moles per liter. That is the solubility of AgCl. If they ask the solubility in grams per liter, solubility in grams per liter, then we have to multiply this with AgCl molecular mass. AgCl molecular mass is 143.5. We'll get the value 1.89 into 10 power minus 3 grams per liter. Okay.